Hi, welcome to the class of Advanced Calculus and Complex Analysis. Today we are going to learn to finding area using double integral. So this is the first question we are going to evaluate to finding the area over the region bounded by the x-axis and ordinate x is equal to 2a and the parabola x square is equal to 4ay. So a is the constant, basically we are considering it is a positive constant. So to evaluate this type of problem, first of all you have to draw a graph. So without graph to evaluate this type of problem, it is very difficult. So and this question is given in the Cartesian form, that means in the xy coordinates. So that means in the xy coordinates you draw a clear graph. So by using this graph we will evaluate it, and this graph will help you to write the limits very easily. So it is given by the x-axis this one, and what is the equation of x-axis? It is known, it is y is equal to 0 and x is equal to 2a. X is equal to 2a. Let us draw the straight line. X is equal to 2a straight line. Okay. So and the parabola x square is equal to 4ay. That means it is in the upper half plane. So in the upper half plane, let us draw the graph of parabola. So this one. So what is that equation? This is actually x square is equal to 4ay. Okay. So now from this graph it is clearly showing that what is the bounded region? Bounded region is this one. So what is the question? We are going to evaluate this problem over the bounded region. That means we are going to find out the area of this region by using this double integration. So what is given in the question? In the question it is given double integration xy dx dy. So you can evaluate this double integration with respect to x first or with respect to y. So my interest to evaluate this problem to evaluate with respect to y first. Why? Next question will come, what why this is with respect to y I am doing, just for better understanding, and you can do it easily. Otherwise you can do with respect to x first also, both the results will come same. Why I am doing with respect to y? So because if what is this curve, this is actually x square is equal to 4ay. So if you rewrite this one, so you will get y is equal to x square upon 4a. Okay, so that means to avoid the square root type of things, I am actually doing the integrations with respect to y first. So now what are the limits? It is I am writing with respect to y first, it is y. So that means first of all you have to write the limits for y first. So and this is very important to evaluate the double integrations. Whenever you are writing the, you are going to evaluate the double integration with respect to one variable so for that one, first time you have to write the limits from one from lower to the upper curve. Basically here that means it is with respect to y. So that means you have to draw a strip which is parallel to y axis. So how, why I have drawn this one? Because to write the limits of y easily. So from this strip, what is the lower part? Lower part actually it is starting from y is equal to 0, and in the upper part it is clearly showing, in the upper part it is y is equal to x square upon 4a. So that means from the graph it is clearly showing that the limits are y is equal to 0 to y is equal to x square upon 4a. So next one, you should write the limits from starting to ending. Suppose, so next one is for x, this is for the x limit. So that means x is starting from this origin to the highest x is equal to 2a. That means it is starting from x is equal to 0 to x is equal to 2a. This is the way to write the limits whenever you will get this type of problems without limit. So fine, so we have written everything, the limits. Now you can do the easily, you can evaluate the double integration easily as usual methods. So first we are going to evaluate with respect to y. So that means x limit, it is as usual, I am not writing again and again. So that means x is equal to 0 to x is 2a. So it is with respect to y, that means x y square upon 2. What is the y limit? It is basically y is equal to 0 to y is equal to x square on 4a and dx. So y part is over and a dx is there. So now what is your aim? You have to substitute the limits for y. So that means upper limit minus the lower limit. Upper limit is x square by 4a. You substitute in place of y, and next minus in place of y you substitute 0. Okay, let us continue that problem. So we are going to substitute the limit for y. So x already it is there, x is equal to 0 to 2a, x is equal to 0 to 2a. If you substitute the limits, so it will come x upon 2 and x to the power 4 by 16 a square, and it is dx. Okay, so just simply we have substitute the limits. So lower limits is actually, it was a 0, so that's why it is not coming. So now you write it again to simplify it. So it is 2a and it is x to the power 5, x to the power 5 divided by 32 a square, 32 a square dx. So 1 by 32 a square, you can take it outside because it is a constant, and now you can easily do the integration with respect to x. It is x to the power 5. So that means you are getting x to the power 6 by 6. And what is the limit for x? Actually x is equal to 0 to x is equal to 2a. Now substitute the limits. So basically you have 1 by 32 a square, 1 by 32 a square, and it is 2a to the power 6, 2a to the power 6 divided by 6, and x is 0, lower limit is 0, minus it will come 0. So then if you now evaluate these things, so it will come automatically, a to the power 4 by, just do some simplification this one. So that means whatever our question was there, to evaluate this one bounded by that three curves, that area is basically a to the power 4 by 3. So you can write it here. So this is the required area, this is the required area. Okay, is it clear to all? So basically in the question limit was not there, but you will get that limit if you draw the graph. Okay, then just if you substitute the limits, then you can evaluate as usual integrations method. Okay, let us say you will get the concept very clearly. So if you solve this problem, the same types of problems, but question is different. It is saying evaluate double integration e to the power y by x dx dy over the region bounded by the straight line y is equal to x, this is one straight line, and y is equal to 0 another one, and x is equal to 1 another one. Okay, three curves are there, basically three curves here, uh, straight lines. No problem, you will get different types of curves, as in the previous question you have seen one curve was actually parabola. You may get there are two curves, and two curves actually parabola like this. Okay, for this question here, three are the straight lines. As I told you, what is your first aim? You draw the graph. It is given in the Cartesian form. So that means we are going to draw a graph in the xy coordinates. You try to draw the graph very nicely. Anyhow, it is for the understanding only. So y is equal to x, it is well known straight line. Y is equal to x means it is a straight line which is passing through origin, and what will be the angle? Angle is 45 degree. You can draw it this side also. Basically the straight line is y is equal to x, y is equal to x, okay, and y is equal to 0. Y is equal to 0, just now we have seen it is basically the x axis. Y is equal to 0. Okay, student. So x is equal to a, x is equal to a, and that means suppose for understanding I am writing, sorry, x is equal to 1, x is equal to 1. So suppose this is my x is equal to 1. Okay, then from the graph you tell me what is the bounded region. So this is clearly showing it is the bounded region. Okay, as we have practiced, suppose with respect to y, we have evaluated the previous question. For this question also will do with respect to y, but as I told you, it is not compulsory. You can do with respect to x also. You will get the same result. It is y by x, and I am doing it dy dx. Okay, it is dy dx, and you can write what are the limits, or otherwise first whatever it is given the question you can write, then the next will continue that one. Suppose it is given as it is dx dy, but in the next I will write it is actually with respect to y. Okay, so now you just here it you will write it, because limits I am going to write from the graph. It is e to the power y by x and dy dx. Okay, so now what will be the limit for y? So for that one, as I told you, what is next? We are going to draw a strip parallel to y axis, because by using this strip you can write the limits for y easily. So what will be the limits? You look at the strip bottom, actually it is y is equal to 0, because you are going to write the limits for y, and look at the strip where it is starting. Strip bottom position is for y is equal to 0, this one, y is equal to 0. And upper position basically it is not a constant, it is basically up to the straight line, because you should not write it is a constant form, because I have drawn this graph here, means that strip is here. If you draw a strip, it is strip here, that means that height is different. If you someone will draw the strip here, that means that height is different. And basically in general it is upper side is up to that straight line y is equal to x. It is basically y is equal to x, that's why it should not come to a constant form. And then next x limit is showing, as I told you, it is from constant to constant, from lower to the highest one. That means x is equal to 0, x is equal to 0 to x is equal to 1. Clear? I mean, in the question limits was not there, you have to write that limits. How do you draw that limits? First of all, you should draw the graphs, whatever it is given, the curves. By using that one you have to draw the graphs. From there you will get a bounded region. So from that, in that region, actually look at there and accordingly draw one strip and that type of things, and you write the limits very carefully. Now you look at here, it is the integration e to the power y by x. You are going to do the integrations, you are going to do the integration with respect to y. Okay, so with respect to y limits also there, and it is e to the power, just already you know the concept how to do the integration e to the power mx, e to the power mx, that form it is. Okay, so let us evaluate with respect to y. So it is basically we are getting x is equal to 0 to x is 1. I am to write it, I am not writing again and again, x is equal to 1. So it is basically 1. 1 means it is the x limit. So now we are doing with respect to y first. So that means e to the power y upon x, and in the below the denominator it is also y upon x. Okay, so and you have to write the limits for y. So y is 0 to y is equal to x, and it is dx is there. So y is over, and we are going to substitute the y limit, but x will do later. So substitute. So that means x is equal to 0 to 1. Okay, now substitute the limit. First you substitute y is equal to 1 here in place of y, then minus of y is equal to 0. Okay, so if you do that one, so this is a very simple calculations. You will get automatically x into e minus 1 dx. Okay, so that means e minus 1, it is a constant. You can write it outside because it is not involved in terms of x. So that's why I am writing it in outside. Now you do with respect to x integration. So that means it is basically x square by 2, x square by 2, and x limits are x is equal to 0 to 1. Okay, so what you are getting the required area. So it is basically, if you substitute the limits clearly, so first x is equal to 1, that means half, and minus is 0, that means 0 will not come. So that means basically you are getting e minus 1 by 2. Okay, and this is your required area. It clear? So that means for this type of problems, integrations are there, but in the integrations, limits will not be there. How do you write the limits? You just look at the graphs. First of all, you draw the graphs. That means you have to identify what is that bounded region exactly. So for that bounded region, you have to write, actually you have to evaluate that double integrations. Okay, and that region will help you to write the limits, because that in the question that limits is not there. Okay, so that means, and for that one, as I told you, you can do with respect to x first or with respect to y first. Actually I am doing with respect to y, because sometimes actually you have seen sometimes suppose y x, if you write, then it will come in terms of square root. So that's why we are writing with respect to y. Okay, so this is actually to avoid that one, to avoid that type of complicacy, we are doing with respect to y. So now then what we will do, you first of all you write the limits. If you write the limits everything very clearly from the graph, then you can evaluate that double integration very easily one by one. Okay, so thank you all.